Hi, I'm Gabe. For this problem, we're asked to approximate this area under the curve x squared plus 1, and we're asked to do so by using rectangles of equal width. So since our goal is to approximate this area using 4 rectangles, 8 rectangles, 20 rectangles, and finally 50 rectangles, let's try to come up with some sort of generalized formula for the area under the curve, or the approximate area under the curve. So since we're dividing this interval up into, let's say n intervals, we know the width of each of our rectangles has to be 1 minus negative 2 divided by n. So the width of each of our rectangles is going to be 3 divided by n. Now the height of each of our rectangles, we want to imagine kind of coming along our function. Well, the heights are going to be given by the function. So the height of each of our rectangles is going to be given by f of our starting point, which is negative 2, our starting x value. And we're going to keep adding our width, which was 3 over n. And since we're looking at multiple different heights, we want to include an I. So what this I comes into play is when we're talking about the summation notation of approximating the area. So let's go ahead and let's actually write out what the height of each of our rectangles is. So we'll substitute this into our function for x. So we'll have negative 2 plus 3 divided by n times I, this quantity squared, and we're adding 1. So we can either simplify here or simplify as we're working through the summation notation. I'm going to simplify here. So let's go ahead and let's expand this. So this is going to be 4 minus 12 divided by n times I, and we're going to add 9 divided by n squared times I squared, and we still have to add 1. So we can simplify a little bit further. So we have 4 plus 1 is 5, and we're still subtracting 12 divided by n times I plus 9 divided by n squared times I squared. So now that we have the height as well as the width of each of our rectangles, we can combine this idea here to actually approximate the area under the curve from x equals negative 2 to x equals 1. So the area is approximately the sum from I equals 1 to n of the height of each of our rectangles. So 5 minus 12 divided by ni plus 9 divided by n squared times I squared. So this right here is the height of each of our rectangles. We now need to multiply by the width, which is just 3 over n. And at this stage, we can go ahead and use the properties of summation as well as a couple formulas to find what this is going to be equal to without involving the summation notation. So let's go ahead and let's try to rewrite this. So since we're thinking about n as being a fixed number, this 3 divided by n can really act as a constant. So we can pull this out in front of the summation notation, or in front of the summation sign. So we have a 3 divided by n. And also, since we have 5 minus 12 divided by ni plus 9 divided by n squared times I squared, we can actually write this as 3 separate sums. So let's go ahead and do that as well. So we can write it as a sum from I equals 1 to n of 5 minus the sum from I equals 1 to n of 12 divided by n times I plus the sum from I equals 1 to n of 9 divided by n squared times I squared. And as I said, we've already taken this 3 divided by n and moved it out front. So here, we can start using some of our formulas and properties. And we have that this is equal to 3 divided by n. The sum from I equals 1 to n of just 5 is 5 times n. Here, we want to pull the same trick that we did from up here. So this 12 divided by n, we can really think of this as just being a constant. So we can write minus 12 divided by n times the sum from I equals 1 to n of I. And we can do the same thing here, where we can think of this 9 divided by n squared as a constant. And pull that out in front of the sum symbol. So now we can go ahead and get rid of these two summation symbols by using the formulas. So this is equal to 3 divided by n times 5n minus 12 divided by n. We know that the sum from I equals 1 to n of just I is n times n plus 1 divided by 2. So we can replace this sum with this. And we'll be adding 9 divided by n squared. And we times, well, this sum here, the sum from I equals 1 to n of I squared, is n times n plus 1 times 2n plus 1, all divided by 6. So at this stage, we have our area as being approximately this expression here. So you could take this a couple steps further and simplify, but since we're just looking to substitute in certain values for n, I'm going to leave this just like this. So to fill in our table, we're asked to find the approximate area when n is 4, 8, 20, and 50. So what we'll do here is we'll just substitute these values into this equation here. So for n equals 4, we have the approximate area is approximately 5.16. For n equals 8, the area is approximately 5.51. For n equals 20, the area is approximately 5.79. And for n equals 50, the area is approximately 5.91. Thank you.